hello and welcome to the FFplus interview episode. Today, we are hosting Dr. Sebastian Mayer, the R&D team at PropertyExpert, which is a German tech company, one of the leading technology and development partners in the insurance and real estate sectors. So, Sebastian, welcome.
Thank you very much for having me here today.
So, to start, could you briefly introduce PropertyExpert company?
Yeah, so PropertyExpert is a technology-driven service provider in the insurance business and real estate business. We're based in Langenfeld in Germany, have around 200 colleagues here, and our customers include major insurance companies, real estate agencies or managers, and we started like 12 years ago, and with a focus on the German market, but we're right now at the edge of internationalizing. So really going abroad and offering our services also to outside of Germany. And what we do, basically, we develop service solutions that combine digitalized processes, artificial intelligence, and human expertise to help regulate property damage as efficiently as possible, and as satisfying as possible for all parties involved. So, typically, so what does that mean? If I explain this with an example, I think that makes it a bit more tangible. So let's take an typical example from the insurance sector. Say you are a homeowner, and now there's a water damage, and you reach out to the constructor of your trust, and it turns out that the water damage comes from a pipe damage. So we're talking about an insured case here, right? So you have a building insurance, and this is covered by this insurance. So far so good, but now, the damage is in the bathroom, say, and your bathroom is tiles, and the tiles are 40 years old. A very typical situation, right? The last time that it has been renovated is a long time ago, and now the tiles have to be removed, or parts of them have to be removed to get rid of to repair the pipe and get rid of the other damage. But it's now very natural to think, okay, if I have to touch that stuff anyway, or have someone work on it anyway, why not make it a whole renovation of the bathroom, right? And replace the old tiles by new ones. This is also a fantastic thing for the constructor, because it makes the job bigger. So he will also be happy with this. But now when you then hand this stuff into your insurance company, there's of course a problem, because the insurance company only wants to cover what is or pay what is actually covered by the insurance policy. And this is now where PropertyExpert comes in. So we check for the insurance company the invoices or offers that are handed in, and check that they are market conform and that it's only about stuff which is covered by the policy, etc. But in the end, what we ensure with this is that it's actually a better process for everyone involved. So for the insurance, for the homeowner, he's protected or she's protected from unpleasant surprises when it then comes to covering costs. For the craftsman or constructor, it's also a better situation, because he can be sure that he actually has a steady payment process and does not have to hassle for payments of done work. And for the insurance company, it's of course a nice thing, because they know that they don't really only pay what is part of the policy. So this is the general business we're doing, and of course, when it started out like 12 years ago, this was really a manual thing. So it was completely we have craft experts here that really do the assessment and checking of the invoices, and but of course, AI plays a more important role. And we also develop our own models, and but I think we come more to this later in this interview.
So thank you for this very plastic actually case, so we can imagine what kind of, let's say, work and solutions can you actually provide. And you mentioned you've been working in your business for almost 2 decades. But let's now focus on today. So from your perspective, what are the most transformative trends that are currently reshaping the insurance and the real estate sectors?
Yeah, that's a very good question. I think the most transformative long-term developments are actually not specific to our branch, but this is climate change and demographic change. Why? So climate change, I mean, we all know that climate change leads to more extreme weather. And more extreme weather means you have more hail or more heavy hail, more heavy storms. It's all more getting stuff gets more unpredictable. You have more floods, all that stuff. And this, of course, means from a property perspective that most likely we will have much more damages in the future than nowadays. Flood damages, storm damages. And on top of that, we will also see more frequently bulk events. So because you have a big storm event, then all at the same time, a huge number of houses is affected. Right? And this is when you now then combine this with demographic change. So demographic change means that there will simply be less people available for doing the work that has to be done, like managing the cases, making the assessments, like so you're less craftsman that can actually judge, is this now okay or not? And this combination is, of course, highly problematic, because it means in the future you have to handle more cases with less personnel. But luckily, there's AI. So I think from this perspective, AI is not just a fascinating technology, but it's really like a lifeline. So I think this is really going. This combination is really transforming how our sectors is working. And if you would now ask me, what are in a nutshell, are there like general trends, if you would now try to formulate it a bit more technically, or in terms of technical developments, I think there's 3 things that stand out. This is first the automation of document processing with the help of AI, and this is what is currently already really heavily happening. Right there, we're right in the middle of the transformation. More and more companies picking up what you can do with ChatGPT, Google Gemini, but also with specialized solutions like the ones we offer. There is definitely something which is going to be more there, is that prevention is going to be a more important topic, so that you need more technical solutions to monitor the states of buildings and prevent that damages occur. Right? And this needs IoT devices, again, AI solutions to analyze patterns and data and so forth. And the third thing I would say is platformization. So that I think if you look nowadays, then you mostly have isolated solutions, so to say, or data silos. And I think what we see much more in the future, or which is already also happening now, is that you see platforms that orchestrate how data is exchanged between insurers, house owners, craft companies, etc. Yeah. And this development also affects our long-term vision. So as a company, we traditionally come from this invoice checking business, but it's clear that in the future, prevention will play a much bigger role for us. So, and if you try it, if you formulate it as a vision, then our goal is that in the future we want that every house owner is protected as best as possible, or the house is protected as good as possible. And if damages occur, which you cannot prevent completely, of course, then these damages are handled as easily and efficiently as fairly as possible.
Mm-hmm. So actually, practically very interesting. And now when we are talking about your digital solutions that PropertyExpert is developing, so using every day, you already walk us in an example at the beginning of our interview. So how you are, let's say, being the intermediate between clients and the property experts or construction companies. Maybe can you share some examples of how do you integrate AI into your workflows for your everyday work, for example, or for your additional solutions?
Yeah, absolutely. So if we stick to this example that I presented in the beginning, the invoice checking process in the insurance sector. So basically this process has three major steps. First is claim completion. So the insurance company sends us the documents, and they have to, in the first place, we have to make sure that all the information is present we need on the claim level. And there you have to do some sort of document completion. Maybe some information is missing and you have to ask again, or some information is it's somewhere hidden and you have to find it and put it into a structured form. And the same thing happens then, but with much more detail also for the invoice. So it's the second step, the invoice completion. Where we have to make sure that the craft company, the details of the craft company are all properly available, that we have all the line items that describe what has been repaired, that all the necessary information there is read out and available to us in a structured form. And then the last major step is the invoice assessment. So actually our craft experts look at these invoices and say, is this now okay or not? And in all of these steps, we nowadays use AI tools to support the people there. So when you look at claim processing, we do stuff that we extract the damage cause automatically from the documents, and we also do stuff like looking for duplicates. So if there's maybe information in there that we have already seen in other cases, maybe then we automatically merge them, or this could also be an indicator for fraud attempts. So stuff like this is also happening. And on the invoice completion, we also do named entity recognition, extraction of all the relevant stuff. And finally, and this is certainly the most challenging thing to automate and which needs the most specialized AI solution, is the invoice checking. And so currently I think you can say we can automate a substantial part of this process, but when it comes to invoice checking, it's mostly that we use the AI as a pre-filter. So which cases are most likely okay, which cases are most likely not okay, so that our craft experts can focus on the not okay cases where they really have to dig in deeper what's wrong here and figure out because sometimes stuff is also just turns out to be misunderstanding and everything is okay, but just some information was missing in the documents. sometimes it's actually the case that that there's stuff in there that should not be there. Like I have the example that I presented in the beginning, that somebody tries to renovate the whole bathroom and not just cover the repairs of the actual damage. So that's and then the models we use is a mixture of self-developed stuff, but also prompting based solutions. So where we build upon big available language models.
So thank you very much for this explanation. Very interesting work. And now I would like to bring this conversation and direct it into the FFplus sub-project, where you also are developing a really innovative case study and using your expertise there. So could you briefly introduce the use case and what challenges does it address and what solution have been you be developing in the last months?
For most of the AIs or the steps that I described previously, most AI models actually have a common backbone that we use. And this is a self-developed foundation model. It's a small foundation model if you compare it to GPT, but it's tailored to our domain. So we particularly made sure that it can deal with this craft language, that it can properly use layout information, and particularly that it can deal correctly with numbers. And this is, of course, very important in our domain, that AI models correctly can calculate, so to say. And so this is what we have at the moment, but this is purely text-based. So it only uses textual information. And as a matter of fact, in a lot of cases, substantial information to make this decision if something is okay or not okay is in images, actually, in case images, right? So when the cases are sent to us, they usually come with images that document the damage, right? Or maybe also what has been done to repair it. And of course, our craft experts work with this, but at the moment, our AI does not work with this. So our fundamental goal, what we want to achieve with FFplus, is that we make our in-house multimodal, our in-house foundation model multimodal, so that it can also work with these case images. That's what we want to, our major goal, what we want to achieve.
And maybe if we shift a bit towards your business outcomes or expectations from this final solution, what, let's say, business outcomes do you see from this sub-project, especially if we are talking about improving operations, competitiveness, or talking about market opportunities?
So I think of course the obvious improvement that we hope for is that our model gets even better in making this okay, not okay decision for invoices. But that's just so to say, that's just the part that directly connects to what we are already doing. In fact, I think that this multimodal foundation model will open up a lot of possibilities for us to go into use cases that are very image centric. Just to give you a couple of examples, that a typical thing which is very image centric is cash settlements. So where you want that actually before having a professional offer from a constructor, the homeowner just sends in a damage documentation, and the insurance company immediately wants to decide whether it makes sense now to just make an offer based on the images, right? And this would be a very great solution that's not out there yet, right? That you can estimate make cash estimates solely based on damage images. Another important use case is comparing before repair documentation with after repair documentation, right? And to see if this fits together, right? If actually the the situation you have before fits to the repair measurements described in the invoice, but it also fits with images that document the renewed or repaired I don't know, window, wall, whatever. No? And of course, this whole prevention thing, right? Images are often a very important source to get an idea in what state part of a property is. In all of these cases, I think this foundation model can be a very good starting point. I mean, I don't expect that you can use that out of the box right directly, right? This certainly needs more research or more development on our side, but I think it's a very good foundation. And why I personally believe that this is very important that we go in this direction is that, I mean, of course, nowadays you have to ask the question with ChatGPT being out there, Google Gemini, all these big language model and vision language models. I mean, for what use case does it actually still make sense as a small company to develop your own stuff? And I think this is exactly one of these situations, because we do regular experimentation. What can these big models do? What are they capable of? And we always see that, they get better, but they, so to say, they get stuck on the level so they don't have more knowledge as a layman, say, right? So whenever judging the situation just requires, let's say, general world knowledge about buildings, as every human being has, then they're good and getting better and better, right? If you just ask them, is that a roof? Or where is the roof? It will find it. But this is not enough to estimate, this is not enough for what we need. We need these detailed craft knowledge, and this is simply not in these models. And so I think this is a very excellent niche for us to still push forward our own developments here.
Yeah, actually, I believe it's a lot of it's complex work, which brings, of course, lots of challenges. And if we focus on that, so you are working as a sole partner in this FFplus sub-project. So have you encountered any kind of specific challenges so far, and how have you been addressing them?
Good question. I think, I mean, if I'm being honest, I think it's the same trap as always, right? So in data science projects or machine learning projects, you always say 80% of the effort goes into data pre-processing, and 80% of the time goes into data pre-processing, cleaning, and only 20% is the thing we actually all love to do, maybe modeling and playing around with cool machine learning architectures and deep learning models. And it's the same here. And if I'm honest, I think we underestimated a bit how much effort it would be to actually start working with these images. So, and I think just to give you two examples, so the first thing that took way longer than we thought until we finally managed to do it is to really compute a full pre-training data set, which consists of millions of images. And for each of these images, we had to, this gets a bit technical now, but just to try to describe it briefly. So the challenge we had there is that for each case image that we have, we had to find examples in our database that would tell the model, okay, this is an image that belongs to the case, and here are similarly looking images that do not belong to the case, and so that the model can learn to distinguish this stuff. I mean, this goes in this direction of contrastive learning. And so in the beginning, it's with the code we already had in place and how we stored the data, it would actually have taken more than a year to compute this data. It would be no human involvement, just the pure stuff, the work the computer has to do, right? This would have taken more than a year. And it actually took us quite a while to get to the point that now we're able to compute the full data set within 6 days. But that was quite a way, and just to give you an impression how challenging this is. So for each individual sample, so in the beginning it took like roughly 2 to 3 seconds to find this counterexample. This is something, if you think of it on a daily basis, we think, what? 2, 3 seconds. This is fast, right? I just have to wait 2, 3 seconds for an answer. Wow, this is fast. But if you scale it up to millions, this is too long. And now now we're at the point that finding these counterexamples takes 55 milliseconds. So, and this we did not anticipate that it would be that we would have to go so deep into database optimization, query parallelization, all this stuff. Yeah. And another thing we also did not anticipate to be that involved is so for our training we have these 2 steps: pre-training, which is, so to say, where you let the machine learning model draw its own conclusions, right? You do not you only mildly steer this process, what the model is supposed to learn. You just give it data, and the model is free to learn correlations, patterns, whatever. But then on top of that, you have this fine-tuning, where you then tailor your model to specific downstream tasking. In this case, the okay, not okay decision making for invoices. And I mean, there, of course, you need data to make this fine-tuning, labeled data to make this fine-tuning, and also to control, have you actually learned something? And for just looking, is the model in the end better on this okay, not okay decision? I mean, this is easy, but we have this information, right? This comes out naturally out of our process, so this okay, not okay label. But say the scenario does not go that smoothly. You do your first training run, and out of the box, everything is better, great, nothing to do on our side. No, but what do you do in the situation where the model does not work out of the box then better on this okay, not okay? How can you produce labeled data that allows you to test in other ways if the underlying foundation model has actually learn to work with images, right? And this was also something which we thought in the beginning. It took us quite some while to a lot of back and forth with our craft experts to get an idea. Okay, how do they actually, what's going on in their minds when they work with these images, and how can we boil that down into something which you can actually, implement into a labeling process that they can do next to their normal work. And this is also something where we did not anticipate that it would take us so much time to figure out these details and find a good balance between complexity of data we record and manageability of this labeling process. So it's always the data generation stuff that breaks your neck.
Yeah. And if we're now moving from this, let's say, data generation and let's say final models tuning, no operations actually can run without solid HPC infrastructure. So what kind of HPC infrastructure have you been using for your study development? And maybe what key takeaways have you gained along the way?
So we do the core model training we do on Meloxina, which is a Euro HPC cluster in Luxembourg. And so there we can do training on multiple nodes, compute nodes, each node having several GPUs. So really, a setup where you can really scale up training, right? But working in such an environment is new for us. So before we worked only in typical hyperscaler environments, where you usually do not let's say the infrastructure is more prepared for you, right? So you don't have to get that much into details how it actually works. And and this is, I would say our key learning is there is definitely a learning curve in the beginning, right? To learn how to work in these classical HPC environments. But once you're there, it's a very excellent environment, I would say, where you can even I think it's absolutely competitive, or even better than what you would get from hyperscalers, I would say, once you have reached this hill of proficiency, say. But that's I would say that's my key takeaway. It's worth the effort getting into this world. Say.
I guess this is a really good lessons learned for someone who would really like to further utilize the HPC for further development. And this actually, brings us to the end of this interview. So let's close it with some final thoughts. So what advice would you give to other SMEs who have not yet explored the use of HPC or generative AI in their business?
Good question. Yeah. I mean, so I already said earlier that, I mean, nowadays, of course, the core question always is, where is it still worth the effort to develop your own stuff? Where can you, I mean, it's clear if we talk about general purpose AI, you cannot compete as an SME with the big companies. This is out of question. So I would say the most important thing is you have to find your niche. You need a very clear use case where it's clear that you as an SME have a chance to stand out technologically with your own development. And this, in the first place, needs a lot of branch expertise, right? Know-how, what is really important in your branch. And I would say it's at least as important, or maybe even more important than machine learning know-how. So that you can identify this use cases. But once you have that, then I would say I can only encourage every SME to seek the opportunity to participate in programs such as FFplus, because it's a great opportunity to do more than you would do without this funding and all this compute support. And for us, honestly, I can say this, having this immense of support through Jura HPC, I mean, it allows us to do experiments we would otherwise probably not have done, right? And get a much more deeper understanding of the models and testing more different alternatives and all that stuff. And but that is in the end what brings you forward, right?
So actually, this is the case of the FFplus, to encouraging the SMEs just to jump into some, let's say, playground and find a proper solution at the end. So, Sebastian, I would like to thank you for this insight interview, and it was actually really a pleasure to have you with us. So thank you, and wishing you all the best in your future endeavors.
Thank you. You too.